This video is part of the ALS Reviewer Series. Ready your pen or pencil and notebook for your answers and computations. The questions in this video are about the lessons in the module How We Move under the Learning Strand 2 Critical Thinking. Question number 1. When is an object considered to be in motion? When is an object considered to be in motion? 1. When its position changes with respect to a point of reference. 2. When its distance changes with respect to a point of reference. 3. When it is moving in a fixed position. A. 1 and 2 only. B. 1 and 3 only. C. 2 and 3 only. D. 1, 2, and 3. We can say if an object is in motion if there is a continuous change in the position of the object with respect to a point or frame of reference. Either the object is moving towards or away from the chosen frame of reference, and in that case, there's also a change in the distance of the object from the given point of reference. So therefore, for number 1, the answer is letter A, 1 and 2 only. Eileen runs exactly 2 laps around the 400-meter track. What is her displacement? Eileen runs exactly 2 laps around the 400-meter track. What is her displacement? A. 800 meters. B. 400 meters. C. 200 meters. D. 0 meter. Okay, let us consider this as the 400-meter track. To answer question number 2, we have to know what is a displacement and how is it different from distance. Distance is the total length traveled by the object. It is a scalar quantity, meaning it has a magnitude and a unit of measure. The examples of the unit in which you can express the distance are centimeter, meter, kilometer, inch, foot, while displacement is the distance from the initial to the final position of the object. Displacement is a vector quantity. It has a magnitude, a unit of measure, and direction. Both distance and displacement have magnitude and a unit of measure, but the displacement has a direction. The displacement can also be expressed in a unit like centimeter, meter, kilometer, inch, foot. Since the displacement is the distance from the initial to the final position, and since Eileen completed 2 laps around a 400-meter track, meaning the initial position of Eileen is also her end position. Therefore, the distance from the initial to the final position of Eileen is equal to 0 meter. So the answer for number 2 is letter D. Number 3. Which of the following is true about an object that travels 100 meters to the left, then 70 meters up, then another 100 meters to the right? Which of the following is true about an object that travels 100 meters to the left, then 70 meters up, then another 100 meters to the right? A. The displacement of the object is equal to 270 meters. B. The total distance traveled by the object is equal to 270 meters. C. The displacement of the object is equal to 70 meters down. D. The total distance traveled by the object is equal to 70 meters down. Okay, to answer number 3, let us analyze every option. Option A, the displacement of the object is equal to 270 meters. Again, displacement is the distance of the object from the initial to the final position. So in this case, the initial position of the object is this, and the final position of the object is this point. So the distance from the initial to the final position is this one. Okay, so obviously the length of this displacement is 70 meters, same as this value. Okay, so the displacement is not equal to 270 meters, but instead 70 meters up. Okay, so the direction of this displacement is upward or to the north. B, the total distance traveled by the object is equal to 270 meters. Let us calculate the total distance traveled by the object. 100 meters plus 70 meters plus 100 meters. Bakit ganun natin i-compute ang distance? Remember, distance is the total length traveled by the object. So therefore, letter B is correct. Okay, the total distance traveled by the object is 270 meters. Let us check letter C. The displacement of the object is equal to 70 meters down. No, the displacement of the object is 70 meters upward or to the north. And then letter D, the total distance traveled by the object is equal to 70 meters down. Okay, the distance is not 70 meters, but 270 meters. For number 3, the answer is letter B. Number 4. A girl leaves the ALS Learning Center room and walks 10 meters north to a drinking fountain. Then, she turns and walks 30 meters south to the library to do research. What is the girl's total displacement from the ALS Learning Center room to the library? A girl leaves the ALS Learning Center room and walks 10 meters north to a drinking fountain. Then, she turns and walks 30 meters south to the library to do research. What is the girl's total displacement from the ALS Learning Center room to the library? A, 20 meters south. B, 20 meters north. C, 40 meters south. D, 40 meters north. Let us have a diagram of this scenario. The first displacement of the girl is 10 meters to the north. That's from the ALS Learning Center room to a drinking fountain. The second displacement of the girl is 30 meters south. That's from the drinking fountain to the library. Okay, so let's consider this Cartesian plane, and let us consider that every grid is equal to 5 meters. So the 10 meters to the north displacement is up to the second grid from the origin. Okay, so let's use a ruler. Okay, so this is, graphically, this is the displacement 1. 10 meters to the north. Displacement 1. Okay, let us connect the second displacement, the tail of the second displacement, to the head of the first displacement. So it's 30 meters to south. So the length of the second displacement, 5, 10, 15, 20, 25, 30, up to this. Okay, so this is the displacement 2. Now, the total displacement is from the initial position. So this is the initial position. Let's use a red color. This is the initial position of the girl, and this is the final position. So obviously, the displacement of the girl is 5, 10, 15, 20, 20 meters where? 20 meters to 20 meters going to south. Just up to this point. Okay? Or mathematically, we can solve for the displacement by getting the sum of, we can solve for the total displacement by getting the sum of the two displacements, d1 and d2. Displacement 1 and displacement 2. The first displacement has a positive sign because it is directed to the north. For the displacement, the positive directions are for the vertical axis, north, for the x-axis, east. The negative direction in the vertical or y-axis is the south, and for the x-axis is the west. So for the displacement 1, the direction is to the north, so it has a positive sign. And the displacement 2 is to the south, so it has a negative sign, so negative 30 meters. Getting the sum of 10 meters and negative 30 meters results to negative 20 meters. Okay, what does a negative sign mean? Meaning that this displacement is towards a negative direction. So we can write this as 20 meters. So the direction is in the vertical axis. The negative direction in the vertical axis is the south. So for number 4, the answer is letter A, 20 meters south. Let's now move on to number 5 question. You ran home from school during lunch because you forgot to pack one. You travel 400 meters north and then realize that you forgot your keys, so you head back to school to get it. Then you travel the 500 meters back to your house, eat lunch, and make it back to school in time for fourth period. What was your total distance traveled? What was your displacement? You ran home from school during lunch because you forgot to pack one. You travel 400 meters north and then realize that you forgot your keys, so you head back to school to get it. Then you travel the 500 meters back to your house, eat lunch, and make it back to school in time for fourth period. What was your total distance traveled? What was your displacement? A. Distance is equal to 1,800 meters. Displacement 0 meter. B. Distance 1,800 meters. Displacement 900 meters south. C. Distance 1,400 meters. Displacement 0 meter. D. Distance 1,400 meters. Displacement 900 meters south. Okay, for number 5, distance 1 is equal to 400 meters. So that's from the school papunta ng bahay, pero hindi pa nakarating ng bahay, nakapag-travel lang ng 400 meters. Then, bumalik sa school, nakalimutan yung susi. So the second distance is also 400 meters. Then, the third distance is from school to house, which is equal to 500 meters. Then, back to school, distance 4 is also 500 meters. So the total distance is the total length traveled. Total distance is equal to 1,800 meters. So dalawa na lang ang pagpipilian nyo, A and B. What about the displacement? The initial position, your initial position is school, and that is also your final position. Therefore, the displacement, which is the distance from initial to final position, is 0. So in this case, the answer is letter A. Distance is 1,800 meters, while the displacement is equal to 0 meter. Number 6. Two runners race each other around the circular track. The track is 690 meters long and 110 meters across, the diameter of the oval. Runner A trips at the halfway mark and doesn't get up. Runner B finishes the race. Which runner has the greater displacement? Which runner has the greater distance? Two runners race each other around a circular track. The track is 690 meters long and 110 meters across, the diameter of the oval. Runner A trips at the halfway mark and doesn't get up. Runner B finishes the race. Which runner has the greater displacement? Which runner has the greater distance? A. Displacement is runner B. Distance, runner A. B. Displacement, runner A. Greater distance, runner B. C. They are the same. D. Cannot be determined. Okay, let's analyze this scenario. So there are two runners, runner A and runner B. Okay, so for the distance traveled by runner A, since hindi niya natapos, halfway lang siya nung track. So the total length of the track is 690 meters. Half of that is 345. So runner A traveled a distance of 345 meters. While runner B, since the runner B finished the race, the runner B traveled a distance of 690 meters. What about displacement? So displacement is the distance from initial to final position. So for runner A, obviously, ang displacement ng runner A is 345 meters. Okay? So hindi niya natapos yung race, pero may na-cover siyang distance from initial to the final position of 345 meters. The runner B, since natapos niya yung race, the initial position of the runner B is also his final position. So the distance from initial to final position of runner B is 0 meter. So therefore, for the distance, runner B traveled a greater distance. So distance, runner B. Okay, so that's for letter B. Displacement is runner A. So displacement, runner A. Distance, runner B. Number 6, letter B. Number 7. What two measurements are necessary for calculating speed? What two measurements are necessary for calculating speed? A. Mass and time. B. Mass and distance. C. Temperature and mass. D. Distance and time. For speed can be calculated by getting the ratio of distance and time. Okay, so therefore, or V equals D over T, where D is the distance, T is time. So therefore, the measurements that are necessary for calculating the speed are the distance and time. So the answer for number 7 is letter D. Okay, number 8. Number 8, which of the following is a measure of velocity? Which of the following is a measure of the velocity? A. 50 seconds. B. 50 south. C. 50 meters per second. D. 50 meters per second north. Okay, for number 8, we have to know what a velocity is. Okay, and let's compare that to speed. Speed is the ratio of distance and time, or this is the distance traveled by the object per unit time. Speed is a scalar quantity, meaning it has a magnitude and a unit of measure. It can be expressed in a unit like centimeter per second, meter per second, kilometer per hour, and so on. While the velocity, we consider the displacement and time. So velocity is the displacement over time. Okay, and it is a vector quantity, so it has a direction. Like the speed, the velocity has a magnitude and a unit of measure. In fact, the velocity, like speed, can be expressed in a unit of measure like centimeter per second, meter per second, kilometer per hour. But the velocity, the distinct difference of the velocity to speed is that it has a direction. So therefore, for number 8, the velocity is 50 meters per second and then direction north, letter D. The 50 meters per second is just a speed. Okay, let's proceed to number 9. A runner races in the 100-meter dash. It takes her 8 seconds to finish. What is her average speed? A runner races in the 100-meter dash. It takes her 8 seconds to finish. What is her average speed? Okay, for the average speed is equal to total distance traveled by the object over the total time. So in this case, the distance or total distance traveled by the runner is 100 meters over 8 seconds. Okay, so for number 9, the answer is, so 100 divided by 8, 12.5 meters per second. Okay, number 9, the answer is letter B. Number 10. A car travels from point A to B in 3 hours and returns back to point A in 5 hours. Points A and B are 200 miles apart along a straight highway. Which of the following statements most accurately describes the motion of the car? A car travels from point A to B in 3 hours and returns back to point A in 5 hours. Points A and B are 200 miles apart along a straight highway. Which of the following statements most accurately describes the motion of the car? Okay, let us analyze every option. A, the average velocity is 50 miles per hour. Let us calculate the average velocity. Okay, for the average velocity is equal to total displacement over total time. So average velocity is total displacement over total time. So what is the displacement of the car if the initial position of the car is point A and that is also the final position of the car? The total displacement is equal to 0 over total time, 8 hours. The average velocity is equal to 0 meter per second. So letter A is not correct. B, the total displacement of the trip is 300 miles. The total displacement of the trip is 300 miles. Again, since the initial position of the car is also its final position, the total displacement is 0 and not 300 miles. So letter B is not correct. Letter C, the average speed is 50 miles per hour. This time, we have to compute for the average speed. Average speed is equal to total distance over total time. The D here is not displacement. Okay, this is distance over total time. V equals D sub T over T sub T. So the symbol for the average speed is just the same with the average velocity. The symbol for the distance is just the same with the symbol for the displacement. But we know the distinct difference between distance and displacement and speed and velocity. So the total distance is, so from point A to B, 200 miles. Then from B to A is another 200 miles. So the total distance is 400 miles. Divide by the total time of 8 hours. Okay, let's calculate 400 miles. Divide by 8. So that is equal to 50 miles per hour. So therefore, letter C is correct. The average speed is 50 miles per hour. Okay, letter D, the car travels at 66.67 miles per hour for the first half and 40 miles per hour for the second half. That's not the way we solve for the average speed. Okay, so for number 10, the answer is letter C. Number 11. The sprinter runs the 200-meter distance at 6.0 meters per second. How long does she take to complete the race? A sprinter runs the 200-meter distance at 6.0 meters per second. How long does she take to complete the race? Okay, how long is for the time. So the given here are the total distance traveled by the sprinter. Let's use a black pen. Total distance traveled by the sprinter is 200 meters. And she covered that distance at a speed of 6.0 meters per second. How long does she take to complete the race? So that's the time. From the equation, speed is equal to distance over time. The time equals distance over the speed. So 200 meters divide by 6.0 meters per second. Cancel the meter unit. So the time is equal to 33.3 seconds. So the answer for number 11 is letter C. Okay, moving on to number 12. Chris cycles at an average speed of 8 kilometers per hour. How far has he traveled if he cycles for 3 hours? Chris cycles at an average speed of 8 kilometers per hour. How far has he traveled if he cycles for 3 hours? Okay, so here we have to solve for the distance traveled by Chris if his average speed is 8 kilometers per hour and if he's moving with that speed for for 3 hours. Okay, so the given speed is 8 kilometers per hour, and then the time moving with that speed is 3 hours. Let's find the distance. Okay, from the equation, speed is distance over time. Distance is equal to the product of speed and time. the speed is 8 kilometers per hour times 3 hours. So let's cancel the R unit. Distance is equal to 8 times 3. That's 24 kilometers. But looking at the options are in a unit of meter. So option A is 5,000 meters, B 11,000 meters, C 24,000 meters, and D 48,000 meters. So we have to convert the kilometer unit of the calculated distance to meter. So 24 kilometers to meter. Remember that 1 kilometer is equal to 1,000 meters. So if we have 24 kilometers or 24 kilometer distance, this is equal to 24,000 meters. Okay, so the answer is letter C. Number 13. Number 13, how far would a cyclist travel moving at 12 meters per second for 3 minutes? How far would a cyclist travel moving at 12 meters per second for 3 minutes? Okay, so the given distance or the given speed here of the cyclist is 12 meters per second, and the time moving with that speed is 3.0 minutes. Okay, since the speed is in a unit of meter per second, the unit time here is in seconds, so we have to convert this minute unit to second. 1 minute is equal to 60 seconds. Thus, 3 minutes equals 180 seconds. Okay, this is 180 seconds. Let's find the distance. Okay, so velocity or speed is distance over time. Distance is the product of speed and time. The speed is 12 meters per second. And then the time or the time is 180 seconds. Let's cancel the unit of time, second. 12 times 180 is equal to 2,160 meters. So that's letter B. Okay, number 14. What is the average speed of a person who swims 105 meters in 70 seconds? What is the average speed of a person who swims 105 meters in 70 seconds? A. 735.0 meters per second. B. 70.0 meters per second. C. 10.5 meters per second. D. 1.5 meters per second. Okay, so the average speed is equal to total distance over total time. Average speed is total distance over total time. The total distance traveled by the swimmer is 100 meters or 105 meters divided by the total time of 70 seconds. Okay, so 105 divided by 70 is 1.5 meters per second. Number 14, letter D. Number 15, one way to get from Cubao MRT to Taft Avenue Station is by riding in a train. The two stations are 10.6 kilometers away from each other. If it takes 21 minutes for the train to reach the Taft Avenue MRT station from Cubao Station, how fast does the train travel? One way to get from Cubao MRT to Taft Avenue Station is by riding in a train. The two stations are 10.6 kilometers away from each other. If it takes 21 minutes for the train to reach the Taft Avenue MRT station from Cubao Station, how fast does the train travel? A. 8.41 meters per second, B. 4.20 meters per second, C. 1.98 meters per second, or D. 0.50 meters per second. Okay, so we have to solve for the average speed. So average speed, again, is the total distance over total time. Total distance over total time. The options are expressed in meter per second. Okay, the given distance here is in kilometer. The given distance is 10.6 kilometers. 1 kilometer is 1,000 meters, so this is 10,600 meters. While the time is 21 minutes. Okay, 21 minutes, 1 minute is equal to 60 seconds. 21 times 60 is 1,260 seconds. So the average speed is 10,600 meters over 1,260 seconds. 10,600 divided by 1,260, that is equal to 8.41. 8.41 meters per second. For number 15, the answer is letter A. Okay, number 16. A group of bike riders took a 4.0-hour trip. During the first 3 hours, they traveled a total of 52.0 kilometers. But during the last hour, they traveled only 8 kilometers. What was the group's average speed for the entire trip? A group of bike riders took a 4.0-hour trip. During the first 3.0 hours, they traveled a total of 52.0 kilometers. But during the last hour, they traveled only 8 kilometers. What was the group's average speed for the entire trip? Okay, so let's analyze. During the first 3 hours, they traveled a distance of 52 kilometers. So distance 1 is 52.0 kilometers. This distance was covered by the riders for 3 hours. And then the last hour, they traveled a distance of 8.0 kilometers. Time 2 is 1 hour. So the total time of travel is 4 hours, and the total distance is 60.0 kilometers. So you don't need to convert the units of kilometer and hour because the options are in kilometer per hour units. Okay, so let's find the average speed. Using the formula, average speed is equal to total distance over total time. So let's get let's divide 60 kilometers by 4 hours. So the answer for number 16 is letter C. 60 divide by 4 is 15 kilometers per hour. Okay, number 17. What is the rate at which velocity changes? What is the rate at which velocity changes? Is it A, motion, B, average speed, C, acceleration, D, instantaneous speed? The rate at which velocity changes is acceleration. Okay, acceleration is defined as the rate of change of velocity. So when we talk about the rate, so if it's a rate of the change of the velocity, so we have to divide the change of the velocity by time. So acceleration is final velocity minus initial velocity over time. Okay, so the unit for the velocity is meter per second, divide by the unit of time in second, so it can be expressed in meter per second square or in kilometer per hour. Oops. Acceleration can be expressed in kilometer per hour square or kilometer per hour per second. Okay, let's now proceed to number 18. The car is moving at a uniform velocity of 50 meters per second in 5 seconds. What is the car's acceleration? The car is moving at a uniform velocity of 50 meters per second in 5 seconds. What is the car's acceleration? A, 0 meter per second square, B, 10 meters per second square, C, 55 meters per second square, D, 250 meters per second square. Again, acceleration is the rate of change of the velocity. Okay, so there must be a change in the velocity of an object to say that there is an acceleration. But in number 18, it is stated here that the car is moving at a uniform velocity or constant velocity of 50 meters per second in 5 seconds, meaning the car is moving at 50 meters per second and the car maintained that velocity for about 5 seconds. So there is no change in the velocity, thus there is no acceleration. For number 18, the answer is A, 0 meter per second square. Number 19. A dog runs with an initial speed of 6.5 meters per second on a wax floor. A dog runs with an initial speed of 6.5 meters per second on a wax floor. It slides to a stop in 15 seconds. What is its acceleration? A, 3.5 meters per second square, B, 2.31 meters per second square, C, 1.52 meters per second square, or D, 0.43 meters per second square. Okay, so again, the acceleration is the rate of change of the velocity. So we have to consider the difference of the final velocity and the initial velocity, okay, over time. But the given here is the speed of a dog. Do not be confused with the speed and velocity here. Now, in a situation wherein the object is moving in a straight path, okay, the magnitude of the speed or the velocity is equal to the speed. So we can use the speed and velocity interchangeably, but you have to remember that the velocity has a direction because it's a vector quantity. Okay, so the magnitude of the velocity can be equal to the magnitude of the speed provided that the object is moving in a straight path. So in this case, the initial speed of the dog is 6.5. The given here is the initial speed of the dog. So we can assume that the dog is moving in a straight path. Initial velocity is 6.5 meters per second. It slides to a stop. Therefore, the final is 0. So nag-umpisa sa velocity na 6.5, then nag-slide, nag-stop. So yun ang gagamitin nating final velocity. Nag-stop na yung dog, so the final velocity is 0. The change of the velocity or speed of the dog from 6.5 to 0 happened in 15 seconds. So nangyari ang pagbabago na to ng velocity from 6.5 to 0 in 15 seconds. What is now the acceleration of the dog? So acceleration final of 0 meter per second minus 6.5 meters per second over 15 seconds. Cancel. So we have negative 6.5 meters per second divided by 15 seconds. So the acceleration here is 0, negative 0.43 meters per second square. Okay, the negative sign here means that the change of the velocity is decreasing, or there is a decrease of the velocity of the object. Okay, so like in this case, from 6.5 to 0. Okay, so this one describes a deceleration, but still it's an acceleration in general. So by just considering the magnitude of the acceleration, so the answer for question number 19 is letter D. Number 20. The speed of a car is increased uniformly from 10.0 meters per second to 50.0 meters per second in 4.0 seconds. What is the car's acceleration? The speed of a car is increased uniformly from 10.0 meters per second to 50.0 meters per second in 4.0 seconds. What is the car's acceleration? A. 15 meters per second square. B. Negative 15 meters per second square. C. 10 meters per second square. D. Negative 10 meters per second square. Okay, so for number 20, there's a uniform increase of the speed of a car from 10 to 50 meters per second in 4.0 seconds. So the initial velocity of the car is 10.0 meters per second, and the final velocity is 50 meters per second. And this change of the velocity from 10 to 50 happened in 4.0 seconds. Okay, so do not be confused with the terms increased uniformly. So it doesn't mean that the car is moving with a constant or uniform velocity for 4.0 seconds. Ibig sabihin lang nito, nagbabago yung velocity niya at a constant value. So starting from 10 to 50 in 4.0 seconds. Okay? So still there's a change of the velocity. But the change of the velocity or the increase of the velocity is uniform. So to solve for the acceleration, let's use the equation final velocity minus initial velocity over time. Okay, and another thing is, ang ginamit na term dito ay speed. For the speed and velocity, you can use the speed and velocity interchangeably if the object is moving in a straight path. Okay? the magnitude of the velocity can be equal to the magnitude of the speed if the object is moving in a straight path. Going back to this, so the final velocity is 50 meters per second minus 10 meters per second for initial velocity over the time of 4.0 seconds. So 50 minus 10 is 40 meters per second divided by 4.0 seconds. So the answer is 10 meters per second square. For number 20, the answer is letter C, 10 meters per second square. Okay, to be updated for more ALS Reviewer videos, please like this video and subscribe in this channel. When performing an experiment or activity in the laboratory to investigate or verify a certain concept or principle, you use laboratory apparatus and equipment. In this video, still as part of your preparation for the A&E test or for whatever test you will take, we will review about the common laboratory apparatus and their uses. Some of the most common kinds of laboratory apparatus and equipment can magnify, measure, ignite, weigh, or hold various substances for a variety of purposes. Prepare paper and pen for your answers. You can check your answers at the last part of the video. The first laboratory apparatus is a thin-walled glass container widely used in the laboratory as reaction container. This apparatus is used for holding liquid and solid samples or catch liquids from different titrations or filtrates from filtering operations. It is used for heating, stirring, and mixing chemicals. It has a spout on its rim to easy pouring. What do you call this laboratory apparatus? Number 2. This apparatus is a glass tube with one end closed and the other end open. It is made of a heat and chemical resistant glass or special type of plastic. This tool is used for mixing, dissolving, and holding liquids, solids, and solutions for heating and observing simple chemical reactions. What laboratory apparatus piece is described and shown in the picture? Next, number 3. This is a measuring tool for the volume of any liquid. This tool is of many sizes and graduations. The 50 ml has 1.0 ml graduation. The 35 ml has 0.5 ml graduation. The 10 ml has 0.1 ml graduation. It has also a lip for easy pouring of liquids. What do you call this laboratory apparatus? 4. This apparatus is used to place liquid samples or to catch filtrates. What piece of laboratory apparatus is this? 5. It is a round flat bottom flask with a long neck, also known as boiling flask. It can be used as a container to hold solutions of chemicals. This flask is designed for uniform heating and ease of swirling. It can be capped by a glass or rubber stopper. But never heat the flask when covered or capped with stopper. It can build up pressure and can result in an explosion. What do you call this laboratory apparatus? 6. This apparatus is a round flask with flat bottom and round necks, which is used to measure the exact volume of liquids. There is a short line on the neck that hints how far to fill the flask. Special cups are available that will not let anything in or out through the flask. This flask is available in different sizes: 100 cubic centimeter, 250 cubic centimeter, 500 cubic centimeter, and 1000 cubic centimeter. The temperature affects the volume, thus always avoid using liquids that will vary in temperature. What do you call this laboratory apparatus? Number 7. This laboratory apparatus is a graduated glass tube with a small aperture and stopcock for delivering measured quantities of liquid. With the use of this apparatus, you can measure or determine the volume of liquids up to nearly to 0.01 milliliter. Its stopcock can be turned to control the release amount of liquid. The markings along the length of this tool indicates the volume of any liquid present in them. By slightly adjusting the stopcock, the amount of releasing liquid can be slowed down to a single drop every few seconds. What piece of laboratory apparatus is this? Number 8. This laboratory apparatus is made up of solid glass, having rounded edges, is slightly thick and longer than a soda water straw. It is often 10 to 45 centimeter long with almost a half centimeter in diameter. This is used for mixing and stirring of different chemicals. What do you call this laboratory apparatus? Number 9. It is a circular convex or concave rounded piece of glass often used to hold a small amount of solid or liquid, to evaporate a liquid while being weighed, and many other purposes. It can be used as a beaker cover to prevent dust from entering in the beaker. What piece of laboratory apparatus is this? Number 10. This apparatus is made up of glass or plastic and has either a long or short stem, depending on the purpose it is needed for. There are a lot of sizes that can be chosen depending upon the amount of liquid that needs to go through them easily and quickly. What do you call this laboratory apparatus? Number 11. This apparatus is used for measuring the exact volume of liquids and transferring liquids into the other containers. Generally, available sizes are 10 cubic centimeter, 20 cubic centimeter, 25 cubic centimeter. What piece of laboratory apparatus is this? Number 12. This is made of thin-walled porcelain. This laboratory apparatus or ceramic ware is used for heating small amounts of materials at very high temperature. The cover is designed to fit the container to prevent loss of materials. What do you call this laboratory apparatus? Number 13. This apparatus is a heavy porcelain dish with a grinder. It is used for pulverizing solids. What piece of laboratory apparatus is of this video below, I attach a quiz on laboratory apparatus and equipment. The Google Forms will require you a Gmail account to access the quiz. Good luck! Don't forget to like this video and subscribe in this channel.